Hi everybody, this is Andrew at Deftaudio, and today we will do another quick product review. I first talk about this and then I'll show a demo. So the topic today is fairly important, I believe, for anyone who is into the Eurorack modular design, and no matter if you're building a small Eurorack skiff or a large system, the typical and the most common issue for all of those is actually a power subsystem. So the power supply and the power budget is one of the most probably important, at least to me, considerations when you design the system, when you put the modules together, not just from the physical perspective, how they fit into the chassis or how you combine these modules next or side by side, but also if you have enough power budget. The good news that most of the Eurorack vendors, they do a pretty good job of specifying the parameters of the power consumption, and to be exact, specifying parameters of the current consumption per voltage rail. And there are 3 voltage rails inside the modular system: +5, +12, and -12. And +/-12, these are typically dual rails that are commonly used in pretty much everywhere that's dealing with the analog or audio or CV and so on. +5 volt rail, well, it's case by case, because originally not many modules really used it, but we see more and more computer-based modules like this that really take a hit on the 5 volt to power up all the digital subsystem of that. So when you open the specifications of these modules, of any modules, you typically see what is a current consumption per rail, which is great because you also can open the specification for the Eurorack chassis, and you can see the power budget. And so basically looking at the power budget and looking at the sum of all the modules inside the system, now you can come up with what is feasible to do with your, well, ability. This is not always the case, because what vendors mostly do, they put the average power consumption. And for many modules, this average consumption pretty much represents how the module is working. For others, that especially digital modules or have some, well, parts that are changing, I will show you some examples of that, the power consumption is not static. It's not linear, so it's dynamically changing depending on the conditions. And the problem is that when you put the system and you use only average power, you can quickly, well, exceed what is your power budget from the power supply perspective. So I've been thinking about that a lot, because that was the case with a smaller chassis like this, with other chassis, how that could be improved or how that could provide more, I would say, visualization of what is actually happening. And I designed that very, very simple module. So what it has 2 ammeters. So these are devices that measure a current. And as I said, you have 3 voltage rails. So this first one on top is always configured to the +12, because it's kind of very important power rail that you should monitor. And the lower one is flexible. It can be configured to -12 volts, or it can be configured to the 5 volts. And you do that by setting up the jumpers on the back. But that's not just it. This module itself is also a bus bar. So the way it works, you connect it to the power supply with the input socket. So you connect it with a standard Eurorack power cable. And the modules that consume the power, they connect straight to this one. So then it could be cascaded to another bus bar if needed, if you run out of available power sockets, and so on and so on. So reason that, well, ammeter, as by the design, it has to stay in the middle between the power source, current source, and current destination. Why I'm using the needle-based ammeters? Well, first of all, because they look really cool. But that's not the main reason. Well, you'll see, and I will show you examples, how that dynamically consumes the power in pretty much in real time. Reacting is what is happening with the Eurorack system. And I think that's very important. You can put permanently into the rack enclosure or Eurorack enclosure and monitor it, what is the consumption, or you can just use it while you're building the system so you know exactly how much current you take. So the ammeters that I'm using here, they are also very flexible. So when you get this module, you pick what is the maximum current rating per indicator, and it can go from the 50 milliamps, 500 milliamps, so it's a half of amp, up to the 3 amps, and that would pretty much cover all the typical designs of these. Also, on the back, so you, as I said, you have the input connector, and all of these connectors are to the Eurorack module, so that's to the destination. Also, here you have the fuses. So per area of a voltage rail, there's a fuse that opens, and you can replace the fuse if it's blown out. And you can set the fuses to, again, to the maximum current that you allow to take. That would be something to protect other modules and to protect other power supply if it's not able to. So very basic module, very cool design, I believe, and certainly it will find its place into many Eurorack enclosures. So now let's take a look how that works. All right, so here you go. This is our Eurorack system for this test. It's quite unusual simply because it sits inside the Navy enclosure, which happens to be the 19-inch rack 3U, and inside it is just a standard off-the-shelf Eurorack kit. So what I have here, fully stock power supply, no changes, no modifications. Then we have the ammeter here, and it's configured to show what is the current consumption on the plus 12 volts and plus 5 volts. Then we have modules, small modules by Deftaudio. So the first module is the motor pod. This is highly programmable, high precision, high torque stepper motor that can be used as the actuator to actually move physical objects. Whatever is, I don't know, knobs, faders, sliders, just use your imagination. In my case, I'm using a silly imagination, and I just connected it with a rubber band to the fidget spinner module. So that's a fidget spinner in front of a guitar pickups, and it's a fully passive. It just, every time it spins, it generates the LFO. Then we have another module which takes a lot of power. So that's a computer, that's a Raspberry Pi with a screen and with MIDI and audio interface. And so it's currently booted to the open source environment called Modep that I'm using quite a lot. So it's a modular environment to do the FX processing or to do some modular synthesis design. And it's quite, well, it's nice to have it in a rack. I'm saying that. So here, what we see, this is happening currently on the plus 5 volts consumption, and you can see that even the system is idle. There is no audio processing, there's no patch loaded. It's still the current fluctuates between the 0.8 amp to 1 amp. And the reason for that is fairly simple. Raspberry Pi is a computer, and it has dynamic processes inside it that are happening. It has a full Linux inside it that's running, and it has a full power management. And so depending on the CPU needs, the power consumption is changing as well. So something that you will not see in the specifications. In the best case, you can see what is the max rating, but typically you will see what is the average current rating for this module. So now let's talk about this module of the motor pod and that connection between these two. Let me run it, and let me show you what is happening that this motor is working. And this stepper motor, it takes the 12 volts as the source for the power. Because it's a high torque, it needs really to be controlled from the higher voltage. And so if I start it, and it's currently started in the mode where it bounces between the two positions so that you can program precisely, and it goes clockwise, then it goes to anti-clockwise, and it goes back and forth between these two. But what you can see that the 12-volt current consumption is radically changing when it flips the position, because in that case, it's dealing with inertia, it's changing the direction of a stepper motor, and it consumes quite a lot of current. So it's just an example, right? Yeah, it's my case, it's quite a special module, but you will see that on many other Eurorack systems, especially on those that have some computational capabilities, because all of that will be dynamic. And it's good to have some insights to monitor what is happening with this in real time and have some precision that only needle indicators can provide. So with that, really thanks. I think it's a nice overview of very small, little, and inexpensive module that you will enjoy. Thanks a lot. See you.